Hello and welcome everyone to SQL Friday. Today is the first presentation of the season, and our guest and star today is Torsten, who will talk about batch mode adaptive join. But before I hand over to Torsten, I would like to share a couple of other community events. So we have the first one I want to talk about is Group By, where if you haven't heard of Group By before, it's an online event, and it works this way. Speakers send in their session abstracts, and then who is going to talk is decided by you. So you get to vote on who is going to be a speaker and which sessions will be presented. So go to groupby.org to cast your votes. Second one is an event by Kay Sauter, I think, or Kai maybe, which is called Data TGIF, Data Thank God It's Friday. So it's also a Friday event, but a little later in the day. If you go to meetup.com/data-tgif, you can register to get the invite for upcoming events. And the last one I want to talk about is Cloud Data Driven, which is driven out of Eventbrite. So just go to eventbrite.com and search for Cloud Data Driven, where you have some pretty good upcoming speakers and sessions. Next one up is William Asaf, who will talk about Microsoft Docs. Enough of that. It's time to hand over to you, Torsten, to make a presentation about batch mode adaptive joins.
Cool. I will take over. Thanks for the invitation. So let me start sharing my screen. Can you see my screen already, or is this? Well, it seems it is. Yeah, it should work now.
Now I see your screen, yes.
Perfect. So that's me. I think it's the second or the third time I'm presenting on SQL Server, SQL Friday. So, and I hope it is not the last time I'm going to present. So this time, as already introduced, I'm talking about batch mode adaptive join, which is a feature which was added in SQL Server 2017. And the main idea of batch mode adaptive join is to, I would say, to handle parameter sniffing issues in a stored procedure to avoid excessive logical I/O reads once plan is optimized for either a selective or non-selective parameter value. So we will see in the presentation that SQL Server allows the engine, the storage engine, to either select the nested loop join or the hash match join during query execution, right? Which is completely new. So I really like the feature, and we will see that in most of the times it is very beneficial. But we also can see that in some scenarios which are, I would say, I cannot explain why it happens, honestly. I spend really hours on figuring out why this specific scenario leads to a worse performance. Yeah, I don't know, I have no clue. But again, there are situations where adaptive joins will perform worse comparing to either the nested loop or hash match join or hash join hint. Yeah? So for sure, you can still avoid that a query will be executed in batch mode adaptive joins by either hinting the query or completely disable the feature on the database. So sometimes it's very useful, or most of the time the feature is very useful, but again, sometimes you will really see a performance decrease, and that is something which is pretty hard to spot. Yeah. Okay, let's give it a try. So first of all, I think it makes sense to understand the different algorithms comparing the nested loop and the hash match join. So we will start with the I would say, I think that's the easiest, the easiest join type. This is the nested loop. And as you can see, the idea of a nested loop is to loop the outer query and the inner query. So we will scan the entire outer query, and for every record we are passing through the pipeline, we are scanning the so-called inner table. So, and once there is a hit, then we will present the data. Otherwise, not. So, yes. So the problem of the nested loop algorithm is for sure that the cost of this algorithm is proportional to the size of the outer table and now multiplied with the size of the inner table. This is completely different comparing with the hash match algorithm, which we will see in a minute. But first of all, consider that the costs are dependent on number of rows multiplied with number of rows. So we always have for sure two tables. The nested loop and the hash match join operator only accepts two inputs. So, and that is the reason why we can always say we have an inner and an outer query, or inner and outer table. And the costs are, I would say, or the other way around, you already understand that once the number of rows of the outer or inner table is growing over time, a nested loop operator will not scale anymore. So nested loop operator is really something the SQL Server engine or the optimizer selects based on the cardinality estimation of the inner and outer query. And once there is a specific threshold, which we will see later, a nested loop operator is not sufficient anymore. It is completely the other way around, looping over millions of rows over and over again is definitely something which cannot scale. So that's about the nested loop operator. Something which is also worth to mention is that the nested loop join operator is the only join algorithm that SQL Server can use without at least one equi-join predicate. So, and this is already a limitation. Once you have, or when you have a query in front of you using, I don't know, logical join, and you have a join predicate which is not written in a way column 1 is equal to column 1 of the other table, then you have a non-equi-join. And the only operator SQL Server can select and implement in the query execution plan to fulfill this logical requirement is the nested loop operator. And that is sometimes already a problem in terms of performance, because you know that I would say when you have a non-equi join predicate, the query will be slow. And again, there is no alternative. There is no hash match. There is no merge join operator available. It cannot be implemented. And that is the reason why, even if you are dealing with millions of rows, but you have to implement a logical non-equi join, SQL Server has and must implement a nested loop. And therefore, you're running in a scaling issue. Right? So therefore, it's definitely worth to think about alternative approaches. Okay, then we have a hash join algorithm, and the hash join is, I would say, once you deal with more records, SQL Server prefers to use the hash join algorithm, because you can see that the cost is not the multiplication between the inner join and the inner table or inner query and the outer query. Instead, it is number of rows, so the build table plus the number of rows of the probe table. Or first of all, you can consider the build and the probe table as the inner and outer query, or inner and outer table, it depends. And therefore, you already understand that this algorithm scales much better. And before I will describe the way the algorithm is created, I think it is worth to explain how the operator is physically implemented. So the hash join is nothing else than, well, we have two phases, I would say. We have a build phase and we have a so-called probe phase. And SQL Server selects the table with a lower number of records, as a so-called inner table, which is nothing else than the so-called build table. So that means when SQL Server starts to execute the query, SQL Server will create a hash table, which is normally something SQL Server can create in memory. That is the reason why we will always see a memory grant once SQL Server implement a hash match or a hash join. So the memory grant is required to create a work table. And again, the work table is nothing else than a specific number of hash buckets, and the number is dependent on the cardinality estimation of the build table. So the more records you have, the more memory grant is required. Even if you, I don't know, if you have a table with 1 million rows and you always have just one single value, so you repeat, I don't know, the number 1 over and over again, but 1 million times, it is still, I would say, you are not requiring just for a hash bucket of one value, you still require for a hash bucket of 1 million rows. At least the memory grant is calculated in this way. So, and this for sure can lead to several performance issues, but I do not want to talk about this. First of all, you should understand that we have a so-called build phase where SQL Server creates hash, or selects a hash function, which can be, I don't know how many hash functions SQL Server can use. I have no clue. There's no documentation, but it is a hash value to replace the column where SQL Server have to compare the values. And the hash value is definitely cheaper than the original value of the column. So all these kind of hash values going to a specific hash bucket, and all these kind of hash buckets are saved in memory. That is why, again, SQL Server needs a memory grant. So, and this phase for sure is blocking, because SQL Server cannot compare the values with the other table before all values of the table are hashed. So once the hash table is in place, once the build phase is completed, SQL Server now scans the so-called probe table, which is, I mean, makes sense, the other table with more records, right? So it's always the selection that build table is the record, the table with less number of rows. And in the probe table, SQL Server now selects the first record, pass it into the pipeline, creates the same hash value using the same hash function, which was used for the build phase. And once there is a match, it will go into the specific hash bucket, because the hash is nothing else than the, I would say, the internal hash bucket address. And within the hash bucket, SQL Server now compares the real value to avoid hash collision. And once the build phase is done and the probe phase starts, the probe phase is not a blocking phase anymore. It's streaming. So that means we have two phases. We have one blocking phase, which is the build phase, and we have one streaming phase, which is the probe phase. And the good thing about the hash match algorithm is that it scales. You have an overhead for sure. The overhead is definitely caused by the build phase. But once the build phase is completed, it is unbelievably fast. Much faster for sure than a nested loop, and also much faster than a merge join. And honestly, I ask, or the other way around, some of from the people from the audience ask me, why SQL Server do not select a merge join anymore? Even if I have indexes on both tables and the columns are used in the join predicate. The reason is that it is when SQL Server as a table reaches a specific number of rows, SQL Server will always prefer to use the hash match because it is even faster than the merge join alternative, where we have all the data already sorted, but nevertheless, the hash join is the fastest implementation here. And that is the reason why the batch match, sorry, the adaptive join algorithm only considers the nested loop and the hash match join. That's it. Okay, I hope you understand the differences here because, again, the nested loop will not scale, whereas the hash match scales, but has an overhead, and therefore it is only considered when we have a specific number of rows in our tables. Cool. You can see how it works here in the algorithm. So for each row in the build phase, begin, calculate the hash value, insert the hash value with a real value into the appropriate hash bucket. This is the build phase, and we have the probe phase. Begin, calculate the hash value of, I would say, the column from table 2. And now for each row in table 2, in the corresponding hash bucket, compared if there's a match, present the row, otherwise present null, depending on the logical join type. Okay, so now let's try to understand the idea of an adaptive join. So the batch match adaptive join feature, and this is what I already mentioned, enables the choice of a hash join or nested loop join method to be deferred until after the first input has been scanned. And by using a single cache plan, and that is the official description from the Microsoft documentation, that is wrong. We will see that we do not have one single plan. In our procedure cache, we will have two plans, depending on the so-called actual adaptive join type. We will see this later. But nevertheless, the idea is start always with the hash join algorithm, which means start always with the so-called build phase. And once SQL Server or the engine detects that the specific and calculated threshold is reached, SQL Server automatically uses the nested loop join. This is exactly what you can see here. Perfect. What you also have to know, because it is very likely, or the other way around, it always starts with a build phase, and therefore the build phase means we are hashing values, and to hash values we need memory grant. And when SQL Server now later switches to the nested loop join, the memory grant for a nested loop is not needed anymore. There's a specific type of nested loop which requires memory grant, but in general, I would say a nested loop does not require memory grant. But again, because we are starting with the hash match algorithm, we are starting with the build phase, SQL Server always requires a memory grant, even if SQL Server switches to the nested loop later on. So you will see that there is an impact in terms of memory consumption, which you have to consider once you have millions of, I would say, well, not millions, but yeah, maybe millions of executions of maybe even the same query using an adaptive join. There are specific requirements, and you can see them here. So first of all, you have to be on SQL Server 2017 or 19. Otherwise, adaptive join is not available. And in order to see the adaptive join operator, you have to use Management Studio 17 at least. Then we have a few other requirements. So first of all, and this is something I guess it changed. I guess this is only true for 2017 because I run all my examples before the presentation yesterday, and I figured out that in SQL Server 2019, there is no need to have a so-called column store index on either the build or the probe table anymore. I'm pretty sure the requirement, or you have to have a column store index in 2017, otherwise SQL Server will not even consider an adaptive join. Yeah. Again, in SQL Server 2019, it seems that there was a change. Okay, and we will see that this is also a requirement. It sounds very simple, but we will see it is not very simple and not very simple to understand. SQL Server at least has to have the opportunity to implement either the nested or the hash match join. So we will see there are some scenarios where SQL Server cannot and will not consider an adaptive join because the nested loop cannot be selected because of several restrictions. So we will see this later on. So there has to be an alternative, otherwise it cannot be a selection anymore. Yeah, okay, that's okay. The adaptive join supports inner join, left outer join, left semi-join, left anti-join, but it does not support full outer join, right outer join, right semi-join, and for sure right anti-semi-join. I mean, a right outer join, it is not a problem because SQL Server is always smart enough to, how can I put it? When we have a left join, it works. When we have a right join, it doesn't work. But SQL Server, again, is smart enough to make the right join or to change the right join in a logical way, so we will end up with a left join, which can be now executed in a hash match or adaptive join operator. And as mentioned, it requires at least one equality-based join predicate, because otherwise the nested loop operator is the only operator which also supports non-equality-based join predicates, but the hash match join does not support non-equality-based join predicates. That is the reason why the adaptive join only works when we have at least one equality-based join predicate, because of the hash match algorithm. Okay, now let's start very simple. So first of all, I use AdventureWorks 2017 because the adaptive join is a database scope configuration. And I will go down to the implementation in 2019 because I'm running on 2019. And we can see that by default value, the batch mode adaptive join is enabled. Okay, this is something you need to know. So whenever there is a choice, SQL Server has at least the opportunity to select and enable the batch mode adaptive join for this specific execution plan. So in 2017, batch mode adaptive join was disabled by default. I don't know what is better. I think it is a good idea to enable this, but really you have to monitor your execution time and wait starts and memory grant, CPU consumption, maybe with the support of query restore. Okay, so you can disable the adaptive join. And you can see this is the database scope configuration by just running a command like this: alter database scope configuration, set batch mode adaptive join set to off. You can see it is off now. For sure we can enable this. It's perfectly fine. So, and you already understand that this feature can be enabled or disabled on a database level. We can do the same on a query level. Again, there are some queries which will run slower using batch mode adaptive join. And therefore, you can hint this specific query to use the either nested loop or the hash join instead. So I cannot run it because the tables does not exist, but you can see the hint here. Okay, wonderful. So let me prepare an example here. So we have the sales order header, which I'm going to use. Just want to make sure that there are specific records where the status is set to 1. So otherwise, all my queries are not running. So that's all. So let us try to understand how SQL Server implements adaptive join in the, I would say, execution plan. So we need a non-clustered column store index, and we will see later on that we can even fake a column store index. Again, I'm pretty sure this restriction or this restriction is not available in 2019 anymore. It seems that this works even without a column store index. I'm not quite sure. Okay, so when I execute this query here and enable the execution plan, which is already enabled, we can see that the join type is the so-called adaptive join type. And there are several properties which are definitely worth to understand. So we have, first of all, the estimated execution mode. So we have a batch mode. Batch mode is something which is available, and here I'm pretty sure only when the table has at least one column store index. So the estimated join type, hash match, is estimated, or is, I would say, considered because of the threshold. So we can see the adaptive threshold in rows, which is currently 1,283. So once this number of records is scanned by the hash match join, so the hash algorithm, so the probe phase, SQL Server automatically uses the hash match algorithm. Otherwise, it will switch to a nested loop. Is there something else we have to consider? Yes, we have to consider that. Okay, so the estimated is the hash match, and the actual join type is also the hash match. That's perfectly fine, and therefore it is not very surprising that we see a memory grant of 206 megabytes. Yeah? And the cost is 480. That's perfectly fine. And we also see that the adaptive join operator, in this case, the logical join is an inner join, has 3 inputs. So we have still the table which is used for the probe phase. Then we have the same, 2 times the same table, what 1 time for the nested loop input and 1 time for the hash match join input. Yeah. This is the only operator, I know at least, which have more than 2 inputs. So when I execute the same query, but just with another predicate, this time I'm looking for all records which have a status of 1, before it was a status of 5. So we can see that this time SQL Server uses the nested loop because the parameter is more selective. Yeah, status 1 is more selective than status 5. And we can see for sure the same properties. And again, I would say the major difference is that the actual join type is now a nested loop, and the estimated join type is also a nested loop, because I recompiled the query to make sure that we also get the right cost, etc., etc. Again, we have 2 inputs and the probe, the build table, so 3 inputs in summary, and we can see that even we have a nested loop operator, SQL Server asks for a memory grant, which is not 206 megabytes anymore. Instead, it is 4 MB. But we ask for a memory grant. So this is an overhead. Let's go down. So there is one specific trace flag which you can use in order to understand how the adaptive join works, which is trace flag 9415. And we can see that this time there is no adaptive join anymore, but instead this is the physical implementation of the adaptive join. So, and it is worth to note that we have a table spool here. And the table spool is there to avoid that the same table, which is the probe table, has to be scanned 2 times. Because one SQL Server decided to switch from a hash join to a nested loop operator. Normally, SQL Server must scan the inner query another time, and to avoid that SQL Server has to scan the same table another time, SQL Server saves all the information in a so-called table spool. So consider a table spool as an in-memory object where we save all the records which were scanned until this point in time. Okay. And okay, I can skip this. It makes it a little bit more complicated. It's perfectly fine. There was also one, well, there is an additional DMV which was, I think, added in 2019, which is called, one second, where is it? Go down. Yeah, this is called Dmxquery plan stats. It's a new DMV which gives you even more information than the DMXX SQL text and query plan. So we will see this. First of all, I just want to mention that this is a DMV which was added, I think, in 2019. Maybe in 2017, I do not know it by heart. That's pretty new. So let's go up and execute this example. I just clear the procedure cache and run this query. We know the query already. This time we can see an adaptive query join. And the actual join type is a hash match, perfectly fine, nothing which is surprising anymore. Running the same query with a more selective status. So here we will end up with a nested loop instead. Perfectly fine. When I now go into the procedure cache in order to find the plans which were created by the 2 executions, that is really nice. I like it because the plan handle always changed. One second. I'm pretty sure I'm able to find this. So it's a little bit hard to find the plan here. Let's do it another time. Yeah, okay. So we can see that we have 2 plans. So these plans were created by the former execution of the 2 statements. And we can see we have an adaptive join with a nested loop, estimated join time nested loop. And we have another one, which is the estimated join type and the physical join type. The estimated join type, which is the hash match. So that means when SQL Server implements an adaptive join, we will end up with more than 1 plan in the procedure cache. I mean, I wouldn't be very, how can I put it, scared about plan pollution here, but at least it is worth to understand that SQL Server actually have 2 plans which can be reused because those plans are part of the procedure cache in order to avoid recompilation. Okay, let's go down. So, one second. It's better. And now it is very hard to understand if the current execution with either the selective or non-selective parameter is preferring the hash or the nested loop adaptive join type. So, and therefore, again, the DMV which was implemented definitely reveals this information. So we have a stored procedure here, which is exactly doing the same as before, but this time we have the status as a parameter. So I will clear the procedure cache and run the procedure the first time. And another the same stored procedure with another parameter value, the non-selective one, also another time. When I now use the information which I have in the procedure cache, I only see one plan here, and I do not have an idea about the current. I only can see the estimated, but not the actual join type. Let's go down. This time we have a nested loop, but again, if I go to the procedure cache, I do not have the actual. I only have the estimated join type. There's a lot of background noise here. Can you please go on mute? That would be nice. Great, thanks. So, nevertheless, there is the DMV, Dmxquery plan stats, and here we can see the last actual execution plan. And the last actual execution plan includes the actual join type and also a lot of more information. We can see the first time actual values, not estimated values. And that definitely helps to understand whether this procedure or the selection and the selectivity of the parameter prefers to use a nested or a hash join algorithm, which is sometimes very, very helpful to understand, to even make performance a little bit better, maybe by hinting the query to avoid adaptive join, and also hint the query to prefer a nested or a hash match join. Because, for example, when I always know that the query is very likely running in a nested loop, why should I spend memory? Why should I have this kind of overhead? And when you are pretty sure that the selectivity and the number of rows will not change over time, it's definitely worth to consider hinting the query to avoid these kind of overhead. But therefore, you have to understand whether it is worth to implement a hash or a nested loop join. Okay, cool. Let's go down. And we can do the same with a non-selective parameter, but I'm pretty sure you get the idea that we will see the actual join type here. So let's go. Okay, this is something I will show you later in Excel. So I have a comparison between the stored procedures and the executions. I will skip this one because otherwise I'm definitely running out of time. So let me go down. As already mentioned, at least in SQL Server 2017, SQL Server only can implement the adaptive join when there is a column store index in place. But maybe you do not want to implement a column store index because it makes no sense. Maybe you have a pure OLTP system. Why should I implement a column store index here? But in order to get rid of this restriction, we can fake a column store index. So this is an example. Create non-clustered column store index on the table, which is either the probe or the build phase, also the build table. It really doesn't matter. Pick one column and filter the column by a predicate which will be never ever true. So you have a fake column store index, which is definitely very cheap in terms of storage and in terms of maintenance. So nothing you need to worry about, but at least again in SQL Server 2017, this was one of the requirements. Okay, I can skip this one. Okay, there is one additional event or extended event which we can use in order to understand when an adaptive join is skipped. And we will see in a moment why SQL Server will skip adaptive joins. But first of all, I will create an extended event. Here you can see how it works. The event is SQL Server adaptive join skipped. So apart from this is just a normal extended event, nothing special about it. Let me go down, refresh, and say adaptive join. Yeah, that's perfectly fine. And say watch live data. Cool. By the way, I will close this one, and go ahead. So there are several reasons why SQL Server cannot implement an adaptive join. And currently we see 8 of them. And honestly, I didn't find an example for all of the reasons mentioned here, but at least for a few of them. Yeah. And now we want to understand why SQL Server cannot implement the adaptive join. And as mentioned, I didn't find an example for all the possible reasons, but there's one example for an invalid adaptive threshold. So let's consider the following. We have a table, sales order header. I create a non-clustered column store index. Again, I'm pretty sure it is not a need in 2019 anymore, but maybe you want to run the same scripts in 2017. There you have to implement a non-clustered column store index. So when I execute this query, we can see that even we have a column store index on top of it, and not even. We can see that we have an adaptive join. So this time we have a hash match because again, status 5 is not very selective. So when I now implement a top operator, top 1, we will see that SQL Server will not implement an adaptive join anymore. Instead, we see a nested loop. So why? It's very logic. So when you consider just to get one record from a big table, you will always get one row back. So why should I run into build and a probe phase? Because again, the hash match algorithm or the hash join algorithm only works, and that is wrong. For sure, it also works for one record, but it is only the preferred solution when you deal with a lot of records. But because you just ask for the very first record and only one record, it makes no sense to implement the hash join algorithm with the build and the probe phase overhead, with a memory grant, and all the overhead I already mentioned. So that is the reason why this time SQL Server definitely knows a nested loop which scales much better for smaller number of records, right? Is definitely the better choice here. So we can see in the extended event that there's one event, adaptive join skipped, and we have the plan handle, which we can now use in order to get the plan and all the SQL tags. We can see a lot of information here, and we can see the invalid adaptive threshold. Yeah? And by the way, this threshold was already defined. We can see the threshold here. The threshold you can see here, which is the adaptive threshold in rows, which is again 1283. This has nothing to do with the name of the extended event. This is not the same adaptive threshold. It only makes sense because SQL Server definitely knows it is not worth to implement a hash match because you only want to get one row. When I now go forward and ask for 1000 rows, now SQL Server considers the threshold the first time, because now it will compare the top 1000 with the internal threshold, and the threshold was set to 1283. When I execute this query now, we still see a nested loop because we didn't reach the threshold. Okay, And again, we will see an extended event, yeah, same reason, and for the same query, but we ask 1,000 for 1,000 records. When I now use the top operator to get 50,000 rows, SQL Server internally definitely knows now it is worth to consider the alternative, either a nested loop or the hash join algorithm. And we can see that this time SQL Server implemented the adaptive join, but still uses the nested loop operator because the tables are pretty large. And that is the reason why we can see the nested loop. I'm a little bit I really wonder, maybe I should use the option recompile. Maybe we will see the hash join instead. Let's see. I don't know. I mean, it's SQL Server choice, right? There's still a nested loop. That's perfectly fine. Okay. Wonderful. Same for option fast one. You know that this is a hint to to make sure that you get the first 10 rows as fast as possible, which makes sense when you have, I don't know, an application and you have something like pagination in place and you only want to see the first 10 rows as fast as possible. And then once the first 10 rows are presented to the application, all the remaining records will be sent to SQL Server. It's a very nice idea because you are definitely not running into a blocking operator anymore. Instead, SQL Server really sends the first 10 rows as fast as possible. For sure, you have overhead for all the remaining rows. That's for sure. Yeah, nothing is for free. But you can consider that this is the same behavior as top 10. Top 100, perfect. Let's go down. There's another one, outer card marks 1. And I do not need the execution plan here. The index sales order detail row GUID is a non-clustered but unique one. That means whenever I ask for a specific row GUID, there will be only one record coming from this table because the index is defined as unique. So that is why this query, where I ask for a specific row GUID, will not consider adaptive joins, because again, there is no need. SQL Server always knows that the amount or the number of records coming from this table, sales order detail, will be 1. So there is no reason to think about a hash match alternative. Okay. Okay, I can skip this one. That's a little bit more complicated to understand, and I was a little bit surprised to prepare the example. Okay, perfectly fine. So we have a column store index on top of it to make sure that we have the support of the adaptive join. And I also have a non-clustered index on the sales order detail table on the modified date. When I execute this query here, we will see the following. We have a key lookup, we have an index seek, and I'm a little bit, and we have, that makes sense. We have a key lookup, we have the adaptive join, we have a nested loop as a preferred actual join type. So the problem here is that the outer table has an index which is currently not covering. We have a key lookup. It still works. When I now execute this example here, we can see that it also works because we still have the key lookup on the outer query. When I execute this query here, we will see that this time SQL Server cannot use an adaptive join anymore because we have two non-covering indexes. Before we had always just one for the outer table, which was table A in the very first example. The second example was exactly the same query, but here we used a non-covering index on table B. This time we have two non-covering indexes for table A and table B. Therefore, we will end up with two key lookups. And once we have two key lookups, it's definitely not a good idea to think about nested loop, because this will not scale. We can for sure simulate, I would say, a nested loop and also a hash join, but this is already a hash join. Or we can implement a covering index. And once we have the covering index in place, we see that, sorry, why it is not working? 1 second. Okay, sorry. This is, sorry, I didn't get it. I did this join match out. Sorry. I don't know. I want to skip this example. Everything I told so far, yeah, is absolutely right. Once we have two key lookups for both, one key lookup for every table, SQL Server cannot consider an adaptive join anymore. I don't know what was the idea of this example. So and now, when we have all these, we understand how the adaptive join works, it is worth to consider how, or the other way around, why an adaptive join is beneficial. Consider the following. We have a stored procedure, and I do not want to implement the stored procedure because I'm running out of time, but I will show you the findings, which is much more important than, I would say, just executing the example here. You can see that I have one stored procedure which does not allow a batch mode adaptive join. We have another stored procedure, and we will have another stored procedure, but then we will execute the stored procedure with a selective and a non-selective value with a recompile. We have another, we will run the same stored procedure another time, but in the other order. So you can see 30, not in another order, but without recompiling. That means it is a selective value. We do not recompile. We execute the same stored procedure with a non-selective parameter, but because of parameter sniffing, the same execution plan is reused, which is horrible in terms of performance, as you can see here already. So memory grant and the number of logical reads is also increasing over time. I have another stored procedure which is doing exactly the same, but without the hint. So therefore, SQL Server can decide whether it is worth to either use a nested or a hash join within the adaptive join operator. So here I leave the decision to SQL Server. And again, I will run the stored procedure first with recompile for the selective plan, another time for the non-selective parameter, also with recompile. And then I execute the stored procedure without recompile with a selective and a non-selective parameter value. And then I switch the order in order to compare everything. So that was the idea. So that is the finding. It's very interesting. So compiled for selective parameter. That means I executed the stored procedure the first time with a selective value. So therefore, this plan is cached. And we can see for sure the because it is selective, the join type. This is not adaptive. This is, I would say, without the adaptive join operator. So and because it is very selective, SQL Server selects the nested loop. So we have a cost, we have a memory grant, we have logical IOs, we have CPU time, and for sure we also have elapsed time. Perfect. It's not a bad plan and not bad statistics. When we now execute the same stored procedure without recompiling, this plan, which was very beneficial and optimized for the selective parameter, the plan is reused for a non-selective parameter. And now you can see what happens. So the logical IOs is up to over 1 million rows because of the nested loop, which will scan the inner table over and over and over again That is a reason why the nested loop is not scaling. It is not suitable for a high number of records. CPU time, you can see here, and the elapsed time for sure is also, it takes much longer. So when I now use the same sort procedure and still disallow to use the adaptive join operator, and I optimize the query for non-selective parameter, so now we can compare what would be the optimal plan, the right side, and with the non-optimal plan on the left side, we can see that for sure the logical number of IOs is reduced and CPU time is reduced, so almost everything is reduced. And for sure the costs are the estimated costs are much higher because the estimated subtree costs are also cached. So the cost of 10 here in the non-selective parameter execution is for sure never ever the right value. The right value is 263. When I execute the same sort procedure once a plan is cached with a selective parameter, we are not in trouble. I would say it is for sure comparing to this execution a little bit slower, and we still have more memory grant. Okay, the execution mode is parallel, but I mean this is still not that bad. This is bad. Now let's compare the execution of the same sort procedure, but with an adaptive join. So for the execution of this sort procedure, I allow SQL Server to use a selective join and defer the selection if it is a nested or a hash match join until execution. So for a selective parameter, we can see that the numbers here are, I would say, mainly the same as we already know from the first execution of the stored procedure without an adaptive join. I mean, the memory grant is a little bit higher, but okay, who cares? Yeah? That's perfectly fine. Now I execute the same stored procedure without recompiling. And now you understand that we will have another plan in cache, which is optimized for the non-selective parameter. And the adaptive join now selects a hash join or hash match join algorithm. The costs are the same because the costs will not be corrected. I'm pretty sure the costs are completely wrong. It should be close to 260. But again, who cares about costs? I don't. Yeah. So for me, IOs, memory grant, CPU is for sure much more important. So CPU time is much more important. But again, we can see that the memory grant is a bit higher, comparing to the first execution of the stored procedure without an adaptive join. But again, who cares? Yeah. So, and logical IOs, perfect, exactly the same. CPU time is a little bit higher than before, but also hard to predict. Elapsed time is almost comparable. And again, when I now execute the same stored procedure with the non-selective parameter, sorry, I repeated this column, I guess. I have to explain this one. The logical number of reads is comparable to the former execution of the stored procedure without the adaptive join. It's exactly, not exactly, but it's almost the same. CPU time, maybe a little bit more because of the overhead of the adaptive join, I think. And the time, I would say it takes a little bit longer. But nevertheless, I care about logical IOs. And we can see that the logical IOs are 245 and not 1 million. So that is caused by parameter sniffing, and that is one solution to avoid parameter sniffing. I mean, you can do the same with a hint option recompile or whatever, but you do not need to worry about recompiling the stored procedure. You just have to allow SQL Server to use adaptive join. We can see that it's the same behavior when I execute the stored procedure again and I allow SQL Server to use the adaptive join. It's almost the same comparing this execution with this execution. It's even a little bit better in terms of elapsed time. I mean, not. Yeah, it's 25 dot. I'm pretty sure. Yes. So okay, it's it's a little bit slower, but again, it is not that slow that I would say it makes no sense to use an adaptive join. And again, when I now execute the same stored procedure using adaptive join with the selective parameter, SQL Server automatically selects a nested loop. And this is for sure comparable with, this is the nest loop with this one, right? The costs, again, are completely wrong because this is coming from the execution plan, which was cached, and the cost will be not corrected. We only see estimated subtree cost, never ever the actual costs. This only works, or the costs are only accurate when you execute the stored procedure with recompile. Then you get the right costs. Yeah. Again, I would say the memory grant is a bit higher. It's running in parallel, okay, but nevertheless, it's much better because I'm not running into the parameter sniffing issue and the so-called tipping point of a read, or I would say in general of a bookmark lookup, which can be either a read or key lookup, right? Which is caused by looping the inner query over and over again, because again, it is not scaling. That is the main benefit of the adaptive query join. It is very unlikely that you run into the tipping point problem caused by the bookmark lookup. That's it, I guess. I have for sure much more to present, but I'm running out of time. I hope you understand at least the idea, and you understand this, that I would say in general, it is definitely worth to consider using adaptive joins in your query to avoid this kind of, I would say, high number of logical reads, which we can see here.
Thanks, Torsten.